Okay. Hi, everyone. Apologies that we're running a little bit late. Could I ask everyone to just mute themselves, please, if you're not on mute? Lots of mechanical keyboards going off, so if I could ask you all to mute yourselves very quickly, thank you. We're just going to wait for a couple more people to join us, and then I'll get the opening address started. Okay. Okay. Just waiting for a few more people to come into the room, then we'll get started in maybe in approximately another 3 minutes, just before 10 past. Please feel free to say hello to each other in the chat. Welcome yourselves, welcome each other in the chat. Just before I get on with the opening address in a couple of minutes. So feel free to say hello to each other in the chat. Okay, great. I think we will get going. So welcome everyone to the Rust Cryptography Interest Group. These are our sync-up calls, and we're very happy to have you here. My name's Ernest, and I serve as your host and general conversation facilitator. And we're really happy to have our fourth one of these as this continues to grow and develop. So this will just be a very brief opening address to welcome all of you to this. Some of you who've been here for the previous ones will know how this goes, but it's just great to also welcome anyone who is here for the first time and new to the Rust Cryptography Interest Group community. So the Rust Cryptography Interest Group serves as a forum and a roundtable for Rust developers interested in cryptography. The purpose of this call and the purpose of these sync-up calls and the community in general is to foster dialogue within the Rust cryptography ecosystem. This isn't about showcasing your own individual projects. It's about all of us within this subset of the Rust community coming together to work out the ways that we can reciprocally help each other and help this part of the Rust community really thrive. cryptography is a very important part of any programming ecosystem. And with the Rust programming language being what it is, it's really important that we have a strong foundation and this part isn't neglected. So we want all of us to come together, regardless of our individual projects, regardless of our individual agendas, and talk and figure out ways where we can help fill out the crate ecosystem, fill out the documentation ecosystem, and generally make sure that we are working together to make this stuff as good as it can be. We're about exploring the current Rust cryptography landscape, diagnosing what's needed together, again, regardless of our individual agendas and projects, and understanding what resources are missing and needed. That's the core purpose of a lot of this, this talking shop here. And we're very excited to have a broad range of people here together to really work on making this happen. So the Rust Cryptography Interest Group is, and these sync-up calls are facilitated and made possible by Concordium and the DevX initiative, which I represent. We're really happy that Concordium is leading the charge on this with a number of partners to really help flesh this out. If you want to find out more about the DevX initiative in itself and what it's about and what it stands for, please follow us on Twitter. If you want to find out more about Concordium and what they do for the Rust ecosystem and Rust itself as a project, please follow them on Twitter as well. And of course, Rust Lang, please follow Rust, the Rust project on Twitter as well. This isn't a sole endeavor. The Rust Cryptography Interest Group community is in collaboration and works in collaboration with the Rust Cryptography organization, which was started by Tony Arcieri at Bascule. I'm sure many of you who are Rust developers know who Tony is. He's a prolific tweeter and an incredible developer, a great personality in the space as well, who unfortunately can't be with us on this call because he's moving. And anyone who's moved house knows before that that's a great endeavor in itself. So we're missing Tony this time round, but he's a big part of this, and we work in collaboration and partnership with his organization to really get all of this stuff going, this community vibrant. We're also in collaboration and partnership with Akamai, with Rich Salz. Say hello, Rich, give us a wave. Are you there on camera? You're still on camera, Rich? Okay, if you can
think I should be.
Yes, yeah, it's great to have you here. Maybe you could actually just give a quick intro on yourself and say very quick TLDR hi to everyone.
Sure. Okay, hi. Yeah, I've been involved with cryptographic toolkits for a way long time, starting back when it was SSL-EAY. I was a member of the OpenSSL project for many years. And my interest in Rust is piqued by Akamai's interest in having memory safety.
Amazing, amazing. Thank you very much, Rich. We also are in partnership with Diego Aranha, Professor Diego Aranha, and Professor Bas Spitters, who isn't here today. Diego, we missed you last time. You were on holiday enjoying a vacation. They both represent the Concordium Blockchain Research Institute of the University of Arhus, and they are also our partners as well. So Concordium, the project, has a research institute as well, which is the research arm of their project. And Diego and Bas both work with that. Diego, do you want to give a quick hi and just introduce yourself really quickly?
Yeah, hello everyone. I'm a professor here at the Aarhus University. I work with crypto engineering and efficient implementation of cryptography in typically insecure computing platforms. And here we do research supporting the Concordium project in that space.
Amazing. Thank you very much, Diego. So Rich and Diego and Tony serve as, again, conversation bootstrappers and facilitators and my co-hosts. So when you have those awkward silences on Zoom calls as you get, Rich and Diego are going to come in and help us navigate through a lot of the topics that we have on the agenda with their own excellent insights as well. So this community, the Rust Cryptography Interest Group, falls under the Berlin Code of Conduct. Again, just really simple, decent human being stuff that we have on these calls. Just be considerate and respectful in your speech and actions. And we do want to encourage and foster robust debate. We want to have discourse and debate about things that need to be done in this space, but we just want to do it within a framework of respect. So that's where we have the Berlin Code of Conduct. That follows on to our etiquette and protocol for raising hands. You know, in this new world of Zoom call meetings, we all know how awkward they can be. We all know how unwieldy they can be sometimes when you want to talk. It's really important to foster discourse, and we want to make it as seamless and unawkward as possible. So if you want to speak, please switch on your video. So the default for everyone will be to have your video switched off, except the co-hosts, So if you have your video off, that's the default. And then if you want to speak, if you want to make a point, switch on your camera, switch on your video, and that will indicate to us that you want to speak, you want to share something. If you want to make a follow-up point, please keep your camera on. If you don't have a camera on your laptop for whatever reason, you can share your point in the chat, and then we will hover in the chat and pick up your points. If you feel too shy that you don't want to necessarily vocalize what you want to say, that's fine as well. We will hover in the chat to pick up your points. If you do want to say something but don't want to switch on your video, you can still use Zoom's hand raising feature, which will have the emoji hand on your profile name. And then that'll also indicate that you want to speak as well. But the default etiquette is switching on your camera and unmuting yourself to indicate that you want to say something. And when you do come up to speak, please just give a quick TLDR of who you are, a quick hello, a quick statement of where you're from and what project you're with. And then we can kind of get to know each other better. And then you can get into a flow of what you want to share. I hope this makes sense. Great. So now that I've finished the opening address, we'll have a quick introduction and recap from the last call, again, for those who are joining us for the first time and those who weren't here. And then we have our core question, which will hopefully spark the conversation. Today, we're going to be focusing on the scope of the awesome Rust cryptography list. We want to talk more about honing in and focusing on the list that we have begun to flesh out. There was already quite a comprehensive list shared by an individual, Michael. Please forgive me if I'm getting your name wrong, Michael. And that was a really good list. We discussed that in the last call. And what we want to do now is, now that we have a website up as well, which is kind of acting as a resource compendium of all of the different crates and tools that are already available, we want to go in further and start discussing two key things. We want to define the scope further, as in defining what this isn't, defining what the list shouldn't have on it, narrowing the scope a bit so that we can get some specificity. And also, we want to talk about the need for guide-like resources. If you're part of the coordination repo, you'll see that there's an issue open by a member of the community specifically requesting for guide-like resources for Rust cryptography. I think that's going to be a great point of conversation for us as well. And those will be things that we discussed here. There is another point about governance as well. I'm not sure if Franciscus is in the room, but if he's not in the room, we may skip that for this call. But there is also a discussion around governance that we will have, maybe if we have enough time, or we may table that for a next sync-up call as well. So those are the main things, and then we'll just end the call on some closing remarks. And we're really excited to have you all here. So I'll start now with a recap on the last call, and I'll start that with Rich, because Rich was here as well. And then we'll go into the main question that we're focusing on now. Rich, you were really, you really coined the term boring crypto, right? And the need for boring crypto. Like when we were talking about the list and we were going through the list on the last call, we discussed that, yeah, there are a lot of nice to haves, and there are also a lot of nice to haves in the specific realms of agenda that people have, whether it's blockchain, whether it's high assurance crypto, whether, you know, but there is also a need for fundamental boring crypto that needs to be fleshed out and sorted out. Did you want to recap maybe a bit more on that?
Sure. First, a disclaimer, I didn't create the term.
Hey, no.
No, it's all right. Either I might have, I probably added a second definition to it. Either Dan Bernstein and or Adam Langley did it. The idea that, you know, crypto, it shouldn't have surprises. And surprises, say in the boring SSL sense, are like, oh, we had a pointer problem and things, and private keys were exposed, Heartbleed. In the DJB sense, oh, this exposes a timing channel attack. Therefore, we should define curves such that implementers will not take the lazy way out. 255.19, for example, always has the high bit on, so you can't skip leading zeros, that kind of stuff. I'll add a third sense to that, which is, you know, the things that have been around for a really long time, that certainly established companies, I'll say, to avoid a pejorative term, need and use. So we have, you know, no surprises, easy to do the right thing or hard to do the wrong thing. And then, yeah, the low slogging, boring stuff. For example, what would it take to do a pure Rust implementation of crypto starting, pure Rust implementation of TLS, say 1.3, all the way down to the level of ASN1 and DIR encoding. And, you know, maybe you'd say boring crypto, or maybe some frankly would call that revolting crypto. But that's the kind of thing that I think to get another kind of the market we would need.
Great. Yes, great. Diego, did you want to come in with any points on your feelings on the fundamentals, the foundational stuff that was needed in just the Rust ecosystem in general?
Not much, yeah, but I would like to point out that there are some things in the list and some things implemented widely deployed in Rust that are less boring. So one clear example is pairing-friendly curves, which have received a non-trivial attack in 2016. And well, some people speculate that this can be improved upon. It's not clear, but it's less, let's call it less boring crypto. It's deployed, right? There is actually a financial stake rely on this, but it's not as boring as ED255.19 and other primitives that have been survived the test of time for longer. Mildly boring then.
Yeah, but it can't be too boring if the IETF is about to publish a document on it, right?
Great. Okay. I'm just going to scan the chat whilst you're saying that. So some of us are here primarily for the boring crypto. It does make the world go round. That is a very, very good point, Greg. And I'm just going to share my screen again, because we have here the website. So again, big thank you to everyone who led the charge on this, but particularly Tony for getting this up and looking great already. And we're already looking at all of the different components and different parts of this that are being fleshed out. And we have here a lot of just from the table of contents, a lot of the different categories that are serving as the headers for the different resources that are needed in the community. So it feels like there's already a lot, right? And the question always kind of leads on to what's missing. But it feels like there's a lot here, right? What do we feel is, like, in terms of just low hanging, is there anything like fundamentally missing from the boring crypto side, right? Because as I scan through, as I'm scrolling through this, there seems to be like a lot here, but I'm not a cryptographer. I'm not really embedded in this space like that, which is why it's important for you folks to really share from your expertise and from your purview what you feel is needed and missing from the fundamentals. I will share this in the chat so that people can also have direct access to it here. But what were some of the things that we even discussed in the last call that we thought were missing from the boring side of things? That's to Rich, Diego, and actually anyone else. So if you want to switch on your camera, if you were here in the last call, please feel free to, and then we can allow you to jump in on this as well. Hello, feel free to unmute yourselves and share.
Yeah. So if Baz were here, he would probably say that more crates should have audited or even verified tags on them. That would be nice to have.
Yes, yeah, he definitely would say that. Yeah. And is that something that does that kind of break off onto a whole different kind of segment of things that we need to focus on? But it's like I'm trying to get down to like the immediacy of things as well, you know. So it's not just like the foundational stuff in general, but it's also the immediacy of things as well. Like what is both foundational, fundamental, and also like needed like now type of stuff that anyone could kind of share they feel is needed in their own projects and things like that. Travis, great to have you, Travis. If you want to unmute yourself, or yes.
Sure. Hi, Travis. I work at Juniper Networks. One thing I can think of is, and I haven't used it myself, but it's a library called Mesolink, which I think uses like Ring, Russell's, and WebPKI to present a C API, C compatible API. Sorry, an OpenSSL C API. So for those of you who have a large existing C code base that uses OpenSSL, it could be a drop-in replacement potentially. No. So I don't know if you would consider that boring, but.
Well, would we consider that boring in a good way?
Yeah, well, yeah, it's in that it uses Rust, but real world, a lot of people use C or C compatible, OpenSSL API. In fact, even in other languages, like, you can imagine a lot of Python packages probably use OpenSSL. So something that can be a drop-in replacement could, transitively affect a lot of stuff.
No, that makes a lot of sense. Thank you. Thank you. And yeah, again, is that something that we would see as boring? I was having a conversation yesterday with someone from the Rust aerospace community, and they were talking about like the dependency on like wrappers kind of brings a lot of shortcomings, and wanting to move away from that, where there are more fully fledged implementations of things that are like pure Rust is something that would be great to have as we develop and grow as an ecosystem. How do people feel about that? Moving away, like maybe from like having to be dependent on wrappers and things like that, and having more fully fledged Rust implementations. Does that make sense, first of all?
Yes, for the other guarantees, right? So one space where this is
Guarantees,
clearly the case is for post-quantum crypto. So you see the two examples listed in the awesome list are wrappers around other libraries. So having, of course, everyone is waiting on this to standardize schemes and maybe to have a clear view of what will be deployed in practice. But it's also quite clear that the time to start writing pure Rust code for some of those primitives is approaching, right? So it has to start at some time.
Yeah, that's really good to hear. Anyone else have any thoughts on that?
Yeah, I think because this is a C wrapper to Rust library, it actually increases the amount of Rust code and then allows you to rebase on top of Rust primitives. And I think, I don't know if there would be potentially other libraries in the future, or if the Mesa library would provide multiple feature flags to say, oh, use this backing crate for your primitives. I think it's, in practice, it's necessary because, there's billions of lines of C code, C++ code that use, OpenSSL, probably more, who knows. And so it is a step in the right direction, I think, especially, you don't want your crypto library introducing memory errors like Heartbleed. At least if it's written in Rust and it's not formally verified, you're like, well, at least there's no memory errors. Maybe there's crypto errors, but get the memory errors out of the way. Yeah.
And this is an interesting point of the kind of like falling into the rewrite in Rust trope. That's something that was really cool, like 2019, 2020, like rewriting Rust, and you see all these massive speed ups and all these benefits, and that is still the case in many areas. But how do we feel that applies to this context, the cryptography context, the rewriting Rust? Do we need to rewrite everything in Rust? Does that make sense? What areas do make sense? And maybe we could focus in on homing in those areas and start picking out those from this list for like maybe immediacy and boring crypto. So now what I'm basically getting into is saying like what makes sense to like have full rewrites on, things like that. And this is open to everyone as well. Whilst I let you ponder that as a question. I'll just scan the chat to see if anyone's made any points there. Okay, yes, Travis, did you see that Richard's asked you to open an issue to add Mesa and include links? That would be amazing if you could do that.
I already did.
Great. Amazing.
Thanks.
Yes.
I think one of the a possible advantage of implementing crypto primitives in Rust is that it shows things that the language might need to add, right? Like the importance of constant time, the importance of not having the Rust compiler is beyond smart, but you don't want it to optimize away things that you are doing for reasons it can't understand. So while it's got a great sort of pragma language, maybe there'll be things we need to do, like keep this object ref around, or this is a local variable that I'm going to zeroize. Don't optimize that out. I'm thinking of tricks that we've had to do in C to say, oh, the compiler says, oh, you're never using this variable after I memset it, so I'm not going to do the memset. Well, it holds key material. I need to memset it to 0. So maybe there are things that the Rust language can learn from as we implement crypto, and we can, feed back to the language team.
Right, and that's a great point. Feedback to the language team. That's actually going to be something really important coming up soon, because we're going to actually need to start sharing this back to the language team and start communicating with them on things as well. Hi, Dimitri, I can see your hand. Please feel free to share. Great to have you again, Dimitri. You can unmute yourself, Dimitri. Let me ask to unmute.
Sorry. Do you hear me now? Hello.
Yes, we can hear you now, Dimitri.
Yeah,
yes.
yeah. Many thanks for organizing the meeting. I would like to join last proposal of Rich. By Rich, we need some solutions on the compiler level to ensure that we really clear the memory and to make more explicit the constant time problem. As various side channel is among the most important threats nowadays. After the memory management and logic faults, if Rust provides some solution to be sure that we can get constant time implementations, it would be great. But I am afraid it should be done on the compiler level. Thanks.
Yes, it would be great to connect you with Franciscus and Bass. I think you folks will, if you're not already, I'm just assuming if you're not already connected with them, because even Diego as well. Diego could come in on this in terms of your own experiments around that, and I think there could be a small group formed around that to kind of tackle some of those issues as well. Diego, do you have any points on that as well?
Not much. I wrote constant time crypto in Rust using the subtotal crate, which is designed for that, right? Has some auxiliary functions you can use for doing linear scans over vectors without triggering cache timing access variation and related. But yeah, this still seemed to be hacky in the sense that they try to deceive the compiler by having indirections and other not long-term strategies, well-designed, built in the language strategies to guarantee constant time execution. So that's a very relevant point. That's not, I don't think it's properly addressed as of now, but we heard, especially on the Hex community, of this proposal of having support to the language to sensitive material that would improve that situation. The secret keyword that was called and raised several times before.
Yeah, so coming back to communicating with members of the core team and members of the language team, members of the compiler team, it may be worth looking at some kind of possible communication to them about that, like maybe a bit of hand waving, like, hey, we found this is going on, like add it to the pile of 10,000 things you already got going on, right? But at least it brings it to their attention in some way, right? So that might be worth looking at and positing some questions towards soon as well. Just scanning the chat, and I've seen Greg has made a really good point. I'm going to scan through the rest of the messages. Greg has shared another boring idea, but not related to bindings. Should we consider a few standard testing crates? Great idea. Oh, there he is. I'll let the man speak for himself. Okay. Great to have you back, man. Haven't seen you in a couple of hours, but yeah, great to have you back.
Yeah, I didn't want to derail the previous good conversation, but one of the things that I'm always disappointed in so many cryptographic libraries in the world I work in is that they never have all the known answer tests. They don't have a lot of the cross-compatibility tests and things like that. I think that Whiteproof from Google has done some amazing stuff there, but it's really, really hard to incorporate it into other projects. So it's gotten better now that they've switched to JSON files as opposed to pure Java. I want crates like that, where we've got like a few truly blessed crates by the community. It's like, if you are going to implement things, you will use the test vectors from this crate.
Yes.
And if you implement the standard traits, you might literally just be able to pass, here's a list of test vectors, here is an implementation of my trait, of the standard trait, and it runs all the tests across it.
I think that would be a great
but
place
just
to
standardized thing for both known answer tests, Whiteproof style edge case tests. I mean, possibly even include a lot of those directly, but also standard API errors. So for example, for Cypher implementations that support not just the single shot interface, but the init, update, 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 final interface. I've seen so many errors where block alignment or not padding properly or just not managing that sequence correctly. And so if we have a trait that implements, if one of our standardized traits exposes that interface, somebody sits down, writes a full test suite for that trait. And now anyone else who implements that trait, if they just give a set of known answer tests and their trait to our tool, it will run the full set of tests across their implementation.
Yeah, no, that sounds really, really important and really good. When I go back, oh, sorry, by the way, this is being recorded. We're like 40 minutes into it now. I'm just letting you all know it's being recorded. Please, if you have any issue with that, let me know, we'll work something out. But Greg, I want to pick that out and really kind of frame that into, this is what we're talking about when we talk about homing in on the scope of things. I think that's a great, great point you've made there. And I think that's something that we can carve out and then also even have maybe a whole call on, to focus in on certain things. Thank you very much for that contribution. Just another really good point from Nicola. Oh, sorry, Rich, did you want to come in before I went to Nicola?
Yeah, I was going to say, the white proof stuff, yeah, as you said, it's in JSON now and not Java, so that's great. But would it also make sense, or is it also worthwhile, I think, to the community to take things like the NIST known answer tests, the various test vectors that are in RFCs, and just you have a crate that's nothing but data. Let's just get the data there so we can run,
I'm still a very new Rust developer. My primary languages are Java and C, C++ still. So, but yes, absolutely. But I would personally like to expose them in a standardized way so that not everybody and their siblings are writing their own, hey, read this file thing. I'd love to have just expose the known answer tests in a standardized interface where you call this method. But other than that, I agree completely. Because one thing I like is that means that, a lot of my test cases could theoretically become 3 lines of code. Load these known answers, get my implementation of the standardized trait, pass to this test implementation that comes from a test crate.
Right.
Some stuff won't be able to be that simple, but.
Sure. Certainly the simple one-shot stuff could just be, import the crate, iterate over the tests in it, and good, bad, yeah. So we can certainly do that as a first step.
Definitely the NIST known answer tests, and a part of it is that sometimes just finding those tests. I've worked with a lot of engineers who have spent days trying to find these tests until somebody knows the magic incantation to use to find the specific test. If somebody spends the time doing that, let's not make every single dev need to find the stupid test vectors.
Right. Yeah, it's the magic URL, right?
Right. I've sent most of these to my computer so that I don't need to search for them next time I implement these things.
Yeah, that's a great point.
Absolutely. Thank you both for that. Yeah, that's really good. A really important points as well. So, yeah, I think that could be a whole thread of conversation, and I really think it's really great to see both of you working through that. I just wanted to go to Nicola's point. Thank you very much for that. What about efforts to collaborate with compiler people to make it possible to let developers express intent regarding constant time behavior instead of hacky obfuscation approaches to try and trick the compiler optimization layers? Yeah, I think those are great points. Apologies for reading that maybe in a hacky way, but did that make sense to everyone? In the sense of like what was already being mentioned by Dimitri to an extent, and Travis as well. I think this is a reinforcement of that point about collaborating with the compiler people to smooth out some of the edges. How does that kind of chime with everyone? Please feel free. And also, Nicola, if you want to chime in to clarify anything I may have misrepresented, please feel free to unmute yourself. You don't have to put on your camera. Just feel free to unmute yourself and share maybe what you really meant, if I've misrepresented anything. And I'm just going to read through some more points in the chat.
Okay. So I think you characterized my question correctly. I think Diego was still talking when I started writing that question, and he addressed something when he said about the secret keyword.
Great.
But that's what I was thinking about. Like many times when you have to write like constant time access to a lookup table, or constant time, even just a comparison between two integers of the same size. Sometimes you have to play all kinds of bitwise tricks to get the compiler not to know that some variable will have some values, and try to optimize away steps that the developer thought he wrote in a constant time safe manner, and then underneath the compiler might change things because it is very smart in its optimization layers. And sometimes it feels like a race between the developers trying to find ways to avoid the compiler optimization layers to achieve constant time binary code in the critical sections, and the compiler people that are making the compiler optimization layers always smarter and smarter. And it feels like a race where collaboration instead would be more beneficial to the whole field.
Yeah, absolutely. Those are great points. And I think there's a lot of kind of group conversations formulating here. And I think we may, I don't know, in the future have breakout rooms in these sync-up calls where, you know, if there's enough of a fleshed out topic to really get into, we may just chuck a bunch of you into a breakout room and have you all folks really flesh it out and have it out and really come up with some great points and solutions to bring back to the group. So thank you for that elaboration, Nicola. It's really cool. Thank you. Just going back to the chat, scanning through the chat, I can see Strad's made a point. Hey Strad, thank you. And it's adding on to Greg's point about testing on microcontrollers. No stud is partial/hacky. I think that's a great point. I think someone's opened up some issues around hardware on the coordination repo as well. So if you do want to elaborate on that, please feel free, Strad. If not, I'll move on to some of the next points. No worries.
That was actually Nicholas Stalder, not me.
Okay, my apologies. My apologies. Nicholas, my apologies as well for getting that mixed up. Again, if you do want to elaborate on that, please feel free to. And again, I apologize for getting you both mixed up. I saw the name and I related it back to Strad from Zcash. So my apologies there. But again, please feel free to elaborate on that more if you want to. No worries. Okay, so I'm going to scan through some more of the thread in negative tests that are too often neglected. Yeah, that's another great point, Nicola. Thank you for that. I'm just going to be looking through for some more insightful points. And then I think we'll get into some of the conversation around resources and guide-like resources that are needed. So the chat is really busy today, so please bear with me. Okay, so Yuri made a very interesting point. I rather doubt it's feasible or practical to have the compiler taking care of generating constant time code. That is a really interesting point. And I think, again, if Bas was here, he would also definitely have something to say about that. Would you like to elaborate on that, Yuri, or was that just that point there? Please feel free to elaborate by just unmuting yourself if you feel the need to.
Probably not, because in general, creating a constant time code doesn't seem to be trivial. And it seems that the chat elaborated on a far simpler and far more achievable goal. Instead of trying to create an optimized or potentially optimized constant time implementation, you just tell the compiler, do not optimize or change this block. Leave it as is. And with the subsequent comment of Rich to add zeroization of what's supposed to be cleared. Just those two low-hanging fruits may get us indeed very far.
Yeah.
Without solving scientific problem of optimized constant time. I suspect this is an oxymoron, by the way. It's either constant time or optimized.
No, absolutely. Thank you very much for those points. Dimitri, did you want to
Sure.
come in? Dimitri, please unmute yourself. Feel free to, yes, great.
Yeah, sure. I wonder if we just explicitly disable the optimization, don't we get significant performance losses?
Let me jump in as a part of a conversation. Absolutely, yes. Which is why instead of just disabling optimization as we can do now for a package or maybe for a file, we disable it for the segment of code, for the function. It's about a granularity of doing that. Just that.
Great. I just want to bring Lucas in. Hey, Lucas, how's it going, man? Great to see you. You want to make some points?
Yeah, so I've written a lot of constant time code. So the thing is, if you look at how Rust subtle is structured, the only tension point is the fact that it represents a Boolean over an opaque byte. And it needs to make sure the compiler doesn't realize what it's doing and realize that it's actually a Boolean. Because if it treats it as a byte that can take any of the values that a byte can have, then the compiler optimizing from that point on can't mess things up because everything's defined in terms of bitwise operations. And if it changes what those operations do, the code is just wrong. So there's really a much smaller point where you have to prevent the compiler from doing optimizations, and that's in transforming these opaque, I think the choice values into Booleans. So that's really the point where you need to perhaps make the compiler aware of what a choice is and not to optimize that specific part. But the algorithm itself, you actually do want the compiler to optimize after that. You want it to maybe, well, to a certain extent.
Yeah, Dimitri, please feel free to come back in if you have something to follow up on that.
No, thanks. Everything is okay. It sounds reasonable, and I think it's the best that can be achieved fast.
Great. No, that's great. Okay, so things seem to be really getting vibrant in the chat, and I'm trying to keep up. But if anyone, if Rich, Diego, if you have any points on that or any kind of musings as I scan through the chat, please feel free. Hey, Nicola, yeah, please come in.
Okay, I just wanted to add that sometimes it's not even just about zeroization, because like you have instances of problems where as a developer, I talk about my C experience, so I don't know if this is also a problem in Rust, but I guess it is because it's my fight against some compiler optimizations. So the problem sometimes is that you wrote your implementation using just bitwise operators and doing proper masking so that you don't have branches in your code depending on the data, for example. But then at some point the compiler is able to recognize that some variable will take only certain values, and all the bitwise logic that you put in there will be just stripped away and replaced with if and jumps. And that's what also the kind of places where you might want to communicate to the compiler, please don't optimize this section that I carefully wrote using all the bitwise magic that I can think of for the constant time behavior. And then, that's the part where I think also communication between the developer intent and the compiler layers is important.
Yes. Yes, Uri, please come in.
This is exactly what I think we have been talking about. Adding a pragma or something like that, that would tell the compiler, this block of code must not be optimized. Nicola, wouldn't that resolve the problems you are describing?
Yes, definitely. It was just to add, because I saw that like the two threads were being a bit mixed, so I didn't want to lose that focus. But this kind of pragma would really be great, like at least as a first step. Then we can think about other steps in like having shared intrinsics to do to let the compiler decide what is the best constant time approach to do an operation depending on the platform where you are, and that will be a next step. But already having a pragma to say, do not compile these very short section, do not optimize this very short section, will be really beneficial. Yes.
Yeah.
My gut says it would be of the kind 80-20. 80% of the benefits and use cases for 20% of cost. Everything else would be, except zeroization, everything else would be in the other part. A 20% of accomplishment for 80% of cost.
Jack, great to have you. Super embarrassed by getting it mixed up. Please unmute yourself and share what you want. Thank you.
No worries. The current discussion just got me thinking a bit about, so we've been focusing just now on the sort of low-level constant time logic in terms of how we could potentially get the compiler or something to not do certain things. Something else that I want to have some thought on, and this is obviously going to go beyond this meeting, but at a high level, how the end user conveys their intent about the privacy or publicity nature of the particular top level things they're working with. So for example, we have a bunch of people who want to do, say, really fast and efficient pairing verification because they're validating, zero knowledge proofs, SCROT16 proofs or something. And they want all the optimizations in the book because they're literally verifying hundreds of thousands of these things. But they want to do that with the same library that is used for implementing the pairing, like creation of the pairings themselves in contexts where you don't want to, or the libraries are used in other contexts where you're doing like, key sign, signature creation. And so the one library catering to both use cases poses a question of how you, how do you settle the best denominator? And at least for the libraries I do, I try and just convince everyone that, make the underlying logic constant time and just live with the performance you get from it. But if there were a way to maybe annotate these at some higher level, then, in terms of like, for example, in some context, a public key, when you're decoding it, is perfectly fine to just do variable time logic for because it's public, doesn't matter if it's leaked. But then there are other contexts where the public key is actually like an intermediate key within a key tree. And so in certain contexts, it's fine. And so in certain contexts, you don't want it revealed. Thoughts around that as well, and whether there's anything that whether the language or the compiler or annotations, whatever, could potentially help there. I don't know.
Lucas, do you want to come back in?
So I actually know how to do this. Well, I've experimented with a way to do this. So you can use const generics actually. So what you can do is you can have your algorithm parameterized by a Boolean, a const Boolean, which says whether or not it's supposed to be constant time. And then inside you can branch on that constant time Boolean or constant compile time Boolean. And that will basically create essentially two versions of your code, one that's constant time and one that isn't. And so then you can, for example, have an elliptic curve for verification where you set the thing to true, and by default it's going to be false. So by default you get the constant time 1, but if you know what you're doing and you know that you're doing public stuff, you can set
that is almost too clever. Like I've thought of using constant time like for just being able to like load fixed points and things like that, but actually switching your implementation that way is devilish.
Yeah, so the problem is that you really want the compiler to guarantee you that when you do this, it will not insert a branch at runtime.
Yeah.
Greg, did you want to come in, Greg?
Yeah, I was going to say, on one hand, I love that. On the other hand, the non-constant time better be significantly slower, otherwise just make it all constant time. And then finally, what's the best way to prove that both of those implementations always give the exact same answer?
Yep. Yeah.
Because if I have something like that, the moment I have two different types of code, I better be able to know they always work identically, which I guess goes back to my whole thing of let's have a test crate. Not that I was trying to get back there, but
yeah, like the direction I'm coming at this from is because as one of the maintainers of a set of trait libraries for sort of abstracting over fields and groups and things. We've sort of made some progress towards making those APIs generally constant time or enabling them to expose constant timeness, but there's still a bit of an inconsistency just due to history at the moment that I'm trying to rectify. But part of the issue there becomes like, okay, if people actively want to use these primitives in ways that they consider should be perfectly fine to do non-const time, the alternatives are either only offer expose a constant time API and you just have to unwrap it and fine and you're stuck with that, or offer two parallel APIs or same name things, and it gets really it expands the API the interface to the point that it just becomes confusing.
The advantage of the constant generics approach is that you can have an implementation that doesn't actually branch itself, because you can basically parameterize the types all the way down the tree. And so basically the high level API using the underlying field type or whatever gets all the benefits of using the variable time code without actually doing anything besides just passing a parameter along. So that's
that needs significant buy-in from the whole stack though.
Right, yeah.
Yeah.
Great. Okay. So I think the flow of conversation is going really well. There was, I did want to pick out a point from Brian earlier that may have been related to this, if maybe wanted to elaborate on about having the black box. I'm just going to run through black box style intrinsics. I mean, if that's probably already been covered through this conversation, then that's fine. But if there's anything that Brian wanted to elaborate on in relation to this, that would be, you're more than open to do that before we start wrapping up.
Yeah, so I've been involved in Rust related cryptography stuff for quite a while, and also kind of how to solve this side channel issue in many discussions. And I think like the one thing that I would encourage people to do is like, if we look at how little progress has been made over the 5 years that we've been talking about having these constant time primitives and like making the compiler learn about constant time types and stuff like that, maybe we should scale back the ambition a little bit to the minimum that we actually need and can actually get into the standard library and into the compiler that isn't so scary for the people that are maintaining the compiler to feel comfortable promising. I think like the idea of secret types is just very scary for the LLVM developers to make a promise that they're going to be able to maintain that correctly forever.
That is a great point. And I just wanted to posit a question on that. I've been described as being able to boil the frog quite well with a number of different people. I know Diego described that once, and funnily enough, someone else said that about the way I approach things as well. So I wanted to posit, like, how do we boil the frog with the compiler team in terms of just like not going in full whole hog with everything, and then again making that a massive load on them. But what's like the smallest incremental thing that we can share before leading on to other things, you think, Brian, or anybody else? Like, how do we boil the frog with that case in particular? Is there something that like we could start really simply with to kind of present to them first and then kind of build from that? Or
So I think that, sorry, I forgot the person's name. Lucas's point about how the subtle crate works, and the fact that it's all hinged on this choice type, which is fundamentally hinged on basically having like a black box primitive. Like I have some primitive value and I want the compiler to forget everything it knows about the bit pattern in this value while it continues to optimize the code. That black box primitive actually already exists to some extent in the Rust testing infrastructure. And if we can move it out of the Rust testing infrastructure, I believe we could implement effectively everything that we need that would be at least as good as what any C implementation could do, which I think is significant progress.
yeah, that sounds really cool. Travis, do you want to comment on that?
Sure, related more on the LLVM backend point, but I guess it would apply for any backend, would be, we were talking about basically ask the compiler to not optimize things. So we would have to think of, at the LLVM IR level, how do you say, don't optimize this? But at the LLVM IR level, it's more so instructions. So what you could potentially imagine is having an optional prefix saying secret or something like that. And then also constant time, because those would be potentially independent. And then the compiler would have to track, which optimizations are safe to do given possibly secret, possibly constant time. And so, at first, in the tree, basically say all optimizations are not safe to do, so we do nothing. But then over time, you could imagine fixing the optimizations to support these to say, oh, you're iterating over this. Oh, well, maybe you can do this level of constant folding at least, or something like that as an optimization, because zero optimization is very slow, potentially. So it would be one way to gradually get optimizations from LLVM, but without, unsafely optimizing something, like adding branches or something.
Yeah, that's really interesting. Lucas, do you want to come in?
Yeah, sure. I think I actually agree with Brian here in that a black box primitive, if it can actually be integrated, because the concern point would be whether or not it works with LLVM, because that's sort of the big hinging point, because that might seem to be a problem. But otherwise, the black box primitive would actually be useful for not only constant time, but also for the zeroing that stuff, depending on how wide we can expand it. Because if you can tell the compiler the value of this is opaque and don't assume anything about it, it can sort of realize you can use that to implement zeroizing in a way that the compiler can optimize away, because it doesn't assume anything about the value after that, potentially.
Thank you so much for that. I'm just going to start wrapping up things now. We've hit an hour exactly from when we started. This has been really, really fun. Is there any final points that anyone wanted to make, like really important? Jack, you're still unmuted. Is there anything that you wanted to add specifically, or was it just the...
Oh, sorry, no, I was muting with my local mic.
No worries at all. But this has been so much fun. This has been so so insightful. I just want to give Rich and Diego a chance to say some final points before I plug away and close down things. So Diego, did you want to go?
No, maybe just clarify that when we speak about optimizing constant time code, of course, we're talking about optimizing what's known sensitive, right? So you could think of a loop unrolling for a loop with fixed number of iterations that can be unrolled safely and still preserve the constant time nature of the operations that happen inside. So there is no actual contradiction between the two. They can compose securely if handled properly. Just a clarification I would like to add.
Yes, thank you very much for that. Rich, any not final words, but like any last words?
Sure. I think after a year plus of video meetings, this is the first one I'm going to actually go back and re-review so
Yes.
that I can make sure I caught point. I mean, yeah. So no, this was a great conversation. I look forward to continuing it very much so.
Absolutely. Absolutely. I think we will continue this conversation. And that's a very important point. There are things that I will go back over and review and chunk out. I'm going to transcribe some stuff as well from this call in particular, because it feels like there are lots of really important conversations happening. So look out for a transcript on that. And then from that transcript, we can actually start fleshing out some, actionables, some really important points, some further points of discussion and collaboration, and then really take another step forward. So this has been really good. This has been a lot of fun. Thank you all for being so open and sharing your thoughts and collaborating and just speaking basically. Please, if you are not part of the RCIG repo, please DM on Twitter at DevX Initiative, or you can DM me on GitHub, just my name, Ernest Kissiedu. And then you'll be added to the DevX organization on GitHub, and you'll have access to the repo. You can open issues, open PRs, and the rest of it. But the best way would be Twitter at DevX Initiative. I'll just add that here. But yes, if you don't do Twitter, you can DM on GitHub, and you can DM me directly on GitHub, and I'll add you to the repo. And that's where we'll continue to kind of flesh out more of the actionables and things like that from there. Thank you all again for being a part of this. And the next, I'm going on vacation in September. I will aim to have another one of these when I get back in the middle of September. That'll be a follow-up. But please continue to even just link up with each other and continue these discussions amongst yourselves. There's the Discord, there's Twitter, there's, everywhere else. And I will have this video up on YouTube for you folks to watch again, and also for you to share with others who may have missed it and benefit from this conversation as well. So a big thank you again. All of you, please enjoy your weekend, and we will see each other in September for the next RCIG. There is also going to be a special announcement made about the first Rust formal verification version of this, which will be happening as well, which is going to act like a sister community to this because of the overlaps that we've just been literally discussing. Bass is going to be working on that, and it's going to be headed by Xavier Dennis. I will be helping out in just this way of, hosting and helping facilitate the conversation. But Xavier Dennis is going to be leading that community and be working with Bass Spitters as well. So there's a lot more to get into, a lot more vibrant things are happening, and watch this space. So thank you all again. Have a great weekend and speak soon. Bye, everyone.